On problems 13 through 18 of worksheet 19, the directions say if each pair of polygons is similar, find the value of x and y. So I want to work a couple of extra problems similar to those. So on these, you do not have to determine whether or not the figures are similar. You're assuming they are in order to find the values of x and y. So your goal is to find what values of x and y maintain that proportionality of the corresponding sides. So to work these and solve for x and y, you're going to set up and solve proportions. Now, proportions are a type of equation, and to solve an equation for an unknown, if you have two unknowns, which we do, an x and a y, then you need two separate equations. So you don't want to have an x and a y in a single equation, or you will not be able to solve for either one of those. So on this first one, when I'm setting up my proportions, we don't have to worry about doing image over original because we're not writing the scale factor. And there's several different ways that I could write the proportion. The main thing is to stay consistent. So a lot of times I write out how I'm going to write my proportions. So for instance, if I want to use the side 6 in my proportion, I could compare it to its corresponding side on the other figure, or I could have a ratio of it and any of the sides on the same figure as it. So for instance, I could do 6 over 12 of the other figure. And so I have a side from the first figure and a side from the second figure that correspond to each other because they're both between the right angle and the one arced angle. Right angle, one arced angle. So these sides correspond to one another, so I wrote them as a ratio. So when I write my second ratio, I want to set up a different ratio that also has corresponding sides. And so at this point, I either want to solve for x or y. I'll solve for x first. So x is of the first figure. So since this number came from the first figure, then in my other ratio, I need to have the first figure on the numerator and the second figure in the denominator. So I'll put the x in the numerator and look over here to see which side corresponds to it. So it's between the right angle and the two arced angle. So right angle, two arced angle would be 16 on the other side. So this is one option for setting up your proportion. There are several different ways to solve this, but this is just one of them. So once you have your proportion, you can cross multiply to solve. So you're multiplying the numbers that are across from each other. So you're going to multiply the 6 by the 16 and get 96 and set that equal to the product of the other cross numbers. 12 times x is 12x. So then to solve for x, we simply divide both sides by 12 and we get our value of x to be 8. Okay, so again, you don't have to do one number from each figure. You can do your first ratio from the same side. So for instance, if I wanted to do 6 over x, that gives me my first ratio with the variable that I'm trying to solve. So I have both of these coming from the first figure. So my ratio on the other side has to both come from the second figure, but I want the corresponding sides to be in the same place. So remember, the 6 corresponded to the 12, so I'd put the 12 in the numerator. The x corresponded to the 16, so I would put 16 in the denominator. Do you see your cross products would be exactly the same thing? 6 times 16, 6 times 16, 12 times x, 12 times x. So those are just a couple of examples of solving for x. So now that I want to solve for y, I need to set up a different proportion. This time I want to make sure to include y. So what side does y correspond to? Well, y is of the second figure between the two right angles, so that corresponds to the 10 of the other side. So I could start off my first ratio as y over 10. This time I started with the second figure in the numerator and the first figure in the denominator. So when I write my second ratio, I want to be consistent. Pick a side from the second figure and a side from the first figure that correspond to one another. You have all these options of sides to pick from the second figure. But I would caution you against picking 16 as the side from the second figure, because even though I now know what x is, that's a number that I came up with. And so if I got this wrong and I used it to help me solve y, I'm for sure going to get y wrong as well. So I would use either the 12 or the 22 in the numerator from the second figure here. So let's use the 22 just to be different. So the 22 from the second figure is between one arc and two arcs, so it would correspond to the 11 of the other side. So second figure over first figure, second figure over first figure. These correspond, these correspond. So just making sure you're really consistent. So now we can cross multiply. Y times 11 is 11y. 22 times 10 is 220. And so then I can divide both sides by 11 to get my y value to be 20. So there's the x and y for that example. Let's look at one more example. So again, we're assuming that these are similar figures. We're told that if they are, to find x and y. So again, to find my x, I'll go ahead and set up a ratio involving x. So I'll put x from the first figure with its corresponding side from the second figure. And this is just one way, again, to set this up. So x is between the 3 arcs and the 2 arcs. So I look over here and I see that the 18 is the side on the other triangle that's between the 2 arcs and the 3 arcs. So when I set up my second ratio, I want a side from the first figure in the numerator, side from the second figure in the denominator, and I want the sides that correspond, just like I did here. So I can pick either the 16 or the 20, but if I pick the 16, the side that it corresponds to on the other triangle is y. So I would have an equation with two variables, which I cannot solve. So I'm going to pick the other side from the first figure, which is between 3 arcs and 1 arc, so it corresponds to the 15 of the other triangle. So first triangle, second triangle, first triangle, second triangle. These correspond, these correspond. So now I can cross multiply. 15 times x is 15x. 18 times 20 is 360. So I can divide both sides by 15 to get my value of x to be 24. Okay, so now I need to find y. And again, I'm not going to use the x value to find the y value, because if this is wrong, then my y would be wrong. So I definitely don't want to do that. So I'll use the y in the numerator of the next ratio. Again, it doesn't have to be in the numerator. The y corresponds to the 16 of the other side, because y is between 1 and 2 arcs, and the 16 is between 1 and 2 arcs of the other triangle. So when I set up my second ratio, remember y came from the second triangle, so the numerator over here has to be from the second triangle as well. And so again, I'm not going to pick the one that corresponds to the x. So I'm not going to pick between 2 and 3 arcs, the 18, because then I would have to use a number I came up with. So I'm going to use the 15 from the second triangle between the 1 and 3 arcs, so it corresponds to the 20 of the other side. So now I can cross multiply to solve. 20 times y is 20y. 16 times 15 is 240. So now I can divide both sides by 20 to find my y value. So y is simply 12. Okay, so on this example, x is 24, y is 12. On this example, x was 8, y is 20. So hopefully that'll help some.